Welcome back to the deep dive, everyone. We had a listener write in, and they shared a really cool article with us.
Oh, yeah, I saw that one.
Yeah, it's about this new desalination technology. Looks like a total game changer,
Potentially, yeah.
especially with clean water being so important.
Yeah.
I know our listeners are always interested in stuff like this.
Yeah, for sure.
And I think this one's especially interesting. It comes from a research team over at the University of Illinois,
Mm-hmm.
and they're working on a new type of electrode.
Right.
And get this, it could be even more efficient than reverse osmosis.
Yeah, that's a big deal if it pans out.
I mean, could this be like the answer to all our water problems?
Well, let's not get ahead of ourselves, but it's definitely promising.
Okay, fair enough. So just to back up a bit for anyone who's not, a desalination expert.
Right.
Most plants nowadays use this process called reverse osmosis.
Mm-hmm.
Works pretty well, but it's got some serious downsides.
Oh, yeah, definitely. Basically, you're forcing salt water through this superfine membrane to filter out the salt.
Right.
But to create enough pressure for that, you need a ton of energy.
Yeah, so I was going to say it's super expensive.
Exactly.
So that kind of limits its use in, a lot of places.
For sure.
And that's where this new method comes in, right? This battery-based desalination thing.
Right.
Using electricity to remove salt, ions, sounds pretty good on paper.
Yeah, much more efficient, potentially.
But, I mean, even pumping water through electrodes, those teeny tiny pores,
Right.
that can't be free energy-wise, can it?
You're absolutely right, and that's where this research gets really innovative. It's not just about using electricity, it's about how they're applying it to move the water.
Okay, so it's like the how is just as important as the what.
Exactly. So in traditional electrodes, you have these dead zones.
Dead zones, like
Oh.
in the ocean.
Kind of, yeah, but in this case, it's areas where the fluid flow is really poor.
Oh, I see. So the water's not moving through efficiently.
Yeah. Exactly, like a highway with a bunch of bottlenecks, you get pressure drops, and the whole system becomes less efficient.
Okay, I'm starting to see the problem. So how do these researchers get rid of these dead zones? Do they, zap them out of existence?
Not quite, haha. No, their solution is, it's actually pretty elegant. They use tapered flow channels inside the electrodes.
Tapered channels, okay. So not just a straight shot through.
Nope. It's wider at the entry point and then gradually narrows, kind of like a funnel.
Oh, like a funnel, so it guides the water through smoothly.
Exactly. No more bottleneck dead zones.
Clever. So how much of a difference does this tapering make? Are we talking like a little improvement or a big jump?
Oh, it's a big jump. We're talking a 2 to 3 times increase in permeability compared to straight channels.
Wow, that's incredible. So this could actually be better than reverse osmosis.
Potentially, yes.
And how much energy are we saving here, roughly?
Well, it's tough to say exactly right now, needs more refining.
Right.
But the potential is there, for sure, to be much less energy intensive than the current standard.
Okay, that's huge if they can pull it off.
Absolutely.
Now, I was looking at the article, and it seems like they didn't just try one design and call it a day.
Oh, absolutely not. This was a very systematic process. They actually created a whole library of designs.
A library, like a literal library.
Well, not literally, haha, but they had 28 different channel designs, all different shapes and sizes.
Wow, 28. That's commitment. I guess science is all about testing and experimenting, not just like one big aha moment.
Exactly. It's about that meticulous process of refinement.
So we've got this potentially revolutionary electrode design, but, and I'm just playing devil's advocate here,
Sure.
even the best design is useless if we can't actually make it right. What about the manufacturing side of things?
That's a really important point. And yes, right now, milling those tapered channels into the electrodes, it's time-consuming.
So not exactly ready for mass production.
Not quite yet. But, as with any new tech, there are bumps in the road early on. I'm confident they'll figure out ways to make large-scale production feasible.
I hope so. This feels like something that could be used for way more than just desalination.
You're right. It could have applications in all sorts of areas. Anything that involves moving fluids through electrodes, really.
Oh, like fuel cells, electrolysis, all that.
Exactly. Even emerging fields like carbon capture, lithium recovery could all benefit from this.
So it's not just about clean water. It's about a whole new understanding of fluid flow.
Precisely. It's about applying these design principles across all sorts of applications.
Wow, that's That's a lot to take in.
Take your time. It's definitely mind-blowing stuff.
Yeah, this is what I love about these deep dives. Always something new to learn and think about.
Absolutely.
But, okay, before we get too lost in the weeds, maybe let's just quickly recap what we've learned so far about this potential desalination revolution.
Sounds good to me.
We started by looking at current methods, like reverse osmosis, with all its drawbacks.
Right. Very expensive. Lots of energy.
Then we jumped into this new battery-based approach.
Which could be much more efficient thanks to these tapered flow channels.
But we did talk about some challenges, right? Like manufacturing these electrodes on a large scale. And even with this new method, we still need energy to pump the water through those tiny pores.
True, and that's where those dead zones we were talking about come in. They really limit the efficiency.
But our clever researchers at the University of Illinois, with their, 28 designs?
Yep, 28.
They found a solution, the tapered flow channels. Just changing the shape made a huge difference in permeability and reduced the energy needed.
It's amazing what a little tweak in design can do.
And then, of course, all the potential uses beyond just desalination. Fuel cells, flow batteries, even carbon capture. It's incredible how interconnected all these fields are. One discovery can lead to breakthroughs in so many different areas.
It really shows you the power of basic research, just asking fundamental questions about how things work.
Exactly. And speaking of questions, I'm curious to hear your thoughts on the potential impact of this technology in the long term. Say, it actually works and we can use it everywhere. What kind of future does that lead to?
Now you're talking. Envisioning the possibilities, that's the fun part. Well, if this technology lives up to its potential, we could see a real transformation in how we deal with water scarcity. Imagine coastal communities, even in dry areas, having access to tons of clean water.
That would be incredible, especially for communities that are struggling with drought and lack of access to water.
Absolutely. And it goes beyond just drinking water. Think about agriculture. We could grow crops in places that were previously impossible to farm.
So we could produce more food in places that desperately need it.
Exactly. And the economic benefits could be huge, too. New industries would spring up around this technology, creating jobs and boosting economies.
It's amazing to think about the ripple effects. It's not just about the tech itself. It's about the societal and economic changes it could bring.
It just shows you how scientific advancements can lead to positive change on so many levels.
Okay, before we get too carried away, we did talk about some challenges earlier, like the manufacturing hurdles and the cost. Even if it's more efficient than reverse osmosis, it still needs to be affordable for people to actually use it.
You're right. We can't forget about those practical considerations. But I'm optimistic. With continued research and development, I think we can overcome those challenges. In fact, this research is already inspiring new research avenues.
Really?
Oh, yeah. People are already looking at ways to improve the manufacturing process, bring down costs, and find even more applications for this type of electrode design.
So this one discovery could lead to a whole wave of new innovation.
Exactly. A chain reaction of scientific progress.
It's an exciting time to be following all this. Feels like we've covered so much already, from the nitty-gritty of electrode design to the potential global impact. I'm feeling pretty inspired.
Me too. It reminds me of why we do this, Science really does have the power to change the world for the better.
I couldn't agree more. Okay, so before we move on to the next part of our deep dive, let's just do a quick recap of the key takeaways. We started by looking at the limitations of current desalination methods.
Right. The need for more efficient and cheaper alternatives.
Then we got into this amazing research from the University of Illinois with their revolutionary electrode design.
With those tapered flow channels that could totally change the desalination game.
They've shown huge improvements in permeability, maybe even better than reverse osmosis.
And we talked about how this discovery could be used in so many other fields besides desalination. Energy storage, carbon capture, resource recovery, the list goes on.
We even talked about the potential benefits for society and the economy. A future with more clean water, more food, and new industries springing up. It's a pretty exciting vision.
It really shows how scientific innovation can help us create a more sustainable and just world.
Absolutely.
Yeah.
But we also acknowledge that there are still some hurdles to overcome, right?
Yeah.
The manufacturing and the cost.
Right, but those challenges are also opportunities for further research and development. I have no doubt that the global scientific community will keep working to refine this technology.
It's an incredible time to be witnessing all these advancements. Now, before we move on, we want to leave you with something to think about. If this technology really takes off, what other industries or challenges could it revolutionize? Imagine the
Okay.
possibilities.
It really does make you think, doesn't it? There are so many potential applications.
Yeah, we talked about clean water, agriculture, but like, what about other resource problems? Could this help with things like mineral extraction or even like cleaning up pollution?
Those are great questions. And you're right, this design could lead to some major improvements in a lot of industries. Like, think about how important efficient fluid flow is in all sorts of industrial processes.
Yeah, this could totally change the game in terms of efficiency and sustainability. Yeah. It's like a domino effect. We could see changes in everything from energy production to waste management.
It really is exciting to think about.
And to think, it all started with this basic question about improving fluid flow through electrodes. Science is pretty cool like that.
It really is. Asking these fundamental questions can lead to some pretty amazing breakthroughs.
Sometimes the simplest questions are the most powerful. And who knows, maybe one of our listeners will be inspired to take this research even further.
I hope so. That's what we love to see.
Inspiring the next generation of scientists, that's what it's all about.
Absolutely.
Well, I think we've covered a lot of ground today, from the really technical details of electrode design to the potential global impact. I'm feeling pretty optimistic. How about you?
Oh, absolutely. It's a good reminder that science can make a real difference in the world, and we all have a role to play in supporting that progress.
Well said. So before we wrap things up, why don't we quickly recap the key takeaways from our deep dive today? We started by talking about the downsides of current desalination methods.
Yeah, the high cost, the energy consumption.
And then we learned about this groundbreaking research from the University of Illinois with their amazing new electrode design.
The one with the tapered flow channels.
Right, which could potentially make desalination even more efficient than reverse osmosis.
And of course, we discussed all the other potential applications beyond just desalination. Energy storage, carbon capture, resource recovery.
It's incredible to think about all the possibilities, isn't it?
It really is. It paints a picture of a future with more clean water, more food, and a whole host of new industries.
And it all stems from scientific innovation. But of course, we can't forget about the challenges. Making this technology affordable and easy to manufacture, those are big hurdles to overcome.
They are, but I have faith in the global scientific community. They're already hard at work finding solutions and refining this technology.
It's truly an exciting time to be following these developments. All right, before we say goodbye, we always like to leave our listeners with a thought-provoking question, something to ponder as they continue exploring this topic on their own. So today, we ask you this. If this technology really takes off, what other industries or challenges could it revolutionize? Imagine the possibilities. So many possibilities. It feels like, we keep coming up with new ones every time we talk about this.
Right. It's like this one discovery has opened up so many doors. Makes you realize there's so much we haven't even thought of yet.
Exactly. Like we mentioned lithium recovery earlier. What if, and this is just me spitballing here, but what if this tech could, totally change how we get lithium from brine?
Oh, that's an interesting thought. That could be a game changer for the whole battery industry, making it more sustainable.
Right. And then it's not just about water anymore. It's about all these other resources and challenges we're facing.
Absolutely. It's like this technology could help us build a more sustainable future across the board.
Imagine a world where, we're not held back by these old, inefficient ways of doing things, where we can, really harness the power of electrochemistry to make things better, cleaner, more efficient,
It's an inspiring thought, isn't it? And it all starts with research like this, with scientists pushing the boundaries.
And it's not just one scientist working alone, right? It's a whole community of researchers all over the world, all contributing.
Exactly, a collaborative effort. Every new discovery builds on what came before.
It's a good reminder that science is about more than just, numbers and formulas. It's about human creativity and problem solving.
Absolutely. It's about using our knowledge to make the world a better place.
And that journey never really ends, does it? There's always something new to learn, always another question to ask.
That's what makes it so exciting, the constant pursuit of knowledge. It's a privilege to be a part of it.
I totally agree. So, to all our listeners out there, we encourage you to keep that curiosity alive. Keep asking questions. Keep exploring. Keep imagining. Who knows what amazing discoveries are waiting for us just around the corner?
The possibilities are endless. Thanks for joining us on this deep dive into the fascinating world of desalination and beyond.
Until next time, keep exploring.